Well, welcome everyone to today's webinar. My name is Jeffrey Palermo, and I'll be your host for the webinar today. I am a chief architect at ClearMeasure, and been a recipient of the Microsoft MVP Award since I think first in 2006. 2006. So that's I guess 16 times. But today we have a exciting webinar topic for you. Also, logistic wise, make sure to pay attention to the chat window. There's quite a few things that I reference that have links or downloads, and I have some help with putting links in there. So make sure to check out the chat. And if you have any questions, go ahead and open up the Q&A window, and I have that open on my side. And if I don't incorporate the answer into the regular content, then I'll make sure to hit the questions at the end. I'm pretty good at making sure that every question gets answered. And if there are any questions that can't be answered in the webinar format, then we can just schedule a quick call later, and I'd be happy to answer those one-on-one. Or if there's any sensitive content, I'll give you my email address as well and phone number, and be happy to visit one-on-one. I love answering questions. So we're going to talk today about Blazor architecture patterns, and there's a lot of popularity around Blazor, Blazor WebAssembly, Blazor server side, and enough time has passed, and we've helped enough clients with software delivery that includes Blazor that we've seen some common things arise. And so I want to share with you some Blazor architecture patterns that just really work well with this new technology and the patterns that this technology introduces. And so we're going to share those. It's going to be really quick hit. This is going to go fast. If you like to take notes, take notes. If you are one that like to, do some screen grabs and annotate them, do whatever you need to. And after the fact, if you miss something, you'll have my email address and phone number so that you can reach out and follow up. But I'm just warning you, this is going to go fast, and there is a lot here that we're going to go through. Okay, so a few resources for those who don't know, or maybe first time on a ClearMeasure webinar. I'm also the host of a podcast called the Azure DevOps Podcast. It's essentially for .NET developers who are shipping software, which looks from the job titles, looks like most of you fall into that category. I know we also have some software management and a few CIOs here on the webinar. Great to have you. But the Azure DevOps Podcast, if you search for Azure or DevOps in any of the podcast directories, it's normally one of the first 5 that come up. But new announcement, this is the first time we've announced it on a ClearMeasure webinar. We have launched a new internet TV show, and it is called Programming with Palermo. And in it, I individually teach the Azure DevOps Podcast. I interview experts in all kinds of different topics, but on this new online TV show, I teach directly, teach concepts. And I don't normally teach like how to use a particular tool, but I think about how to think about a particular concept in the context of a tool. And so we've launched. We have 10 episodes recorded. We don't have all of them published just yet, but I think the first 7 are published at the time of today. And I put one of them on the screen because there is one related to Blazor. It's not specifically about Blazor directly, but how to think about the integration of Blazor WebAssembly and a backend process when it comes to WebAssembly, when it comes to web API. So you can go to www.palermo.network, and you can get all those, and you can subscribe to that show as well. Okay. In the chat, someone said, I don't hear you. Can I get a volume check? Can anyone else hear me? Or do I have an issue on my side? Someone says, I don't hear you. Can anyone else hear me? If you wouldn't mind putting in. Okay. Thank you all. Thank you all. So Sir, if you're having trouble hearing, uh, hopefully that issue can get worked out. Awesome. Awesome. Thank you so much. All right, let's get into it. We have a lot to cover. I do want to give every one of you something of value. If this would be valuable to you, my latest book is .NET DevOps for Azure, and if you want to send me an email, I'd be happy to give you an electronic copy of the book, an individual electronic copy of the book. You can also buy the print book anywhere print books are sold. And it's about DevOps in the .NET ecosystem, and all the examples do use Azure, but all the concepts are transferable. All right, now let's get into Blazor. So let me give you some context, because there is a particular project that I think a number of these patterns came from, and then there's some other projects that have corroborated some of the patterns. But we do have permission to actually show you some screenshots from a particular project. And this one is in livestock auctions for county fairs. And actually, this application is in Microsoft's .NET Showcase. So if you go to the .NET Showcase, it's one of the Blazor applications there, and a write-up is there. But this is the context is high intensity auctions. And in this context, yes, you need to show pictures. You need to show that someone is bidding on a particular animal, that the current winner is such and such. And in this space, there's an auction barn, and an auctioneer is running really, really fast, and that's one context. And so people who are not physically there want to keep up with who bought what animal and what the current prices are. And then there's also the context of add-on donations. A different mode of the auction is a purely online or silent auction, not only silent because you know who's bidding, but an online only auction where someone is bidding, and then the bidding for a particular animal is going to close at a certain time. If anybody's familiar with eBay, that's one of the really popular modes there. And so this has a good amount of logic in it, but there's an actual intensity about this type of software, and that is real-time notifications and real-time updates, especially with the online nature of it, where bidding is going to close on a particular date and time and second. If someone outbids you, you need to know what the price is. You need to know the updated price immediately. And Blazor really works well, because it would have been a lot of custom JavaScript or Ajax for callbacks to try to get real-time notifications, where Blazor updates the screen directly, and then behind the scenes, a SignalR hub was doing the close to real-time notification. So that's the context of one of these pieces of software, so that you can kind of relate. When we talk about some of the patterns, I'll tell you if it came from this one or not. Also, this system had multiple applications as a part of the whole system. Another was digital signage. Okay. And so this is inside the auction barn at one of the county fairs. And it's a really big screen TV. It's probably 85 inches or so. Some of the fairs have even larger screens and whatnot. But effectively, it's digital signage. It is run by just a little either a smart TV or a Roku stick, or maybe an Amazon Fire TV stick plugged into the HDMI port, or you can connect a computer. But it's digital signage, and Blazor server side runs natively on any browser that supports WebSockets. And so all these smart TVs, the software and the browsers that are embedded in them support WebSockets. So you automatically get digital signage. Now, for digital signage, there's no user input. There's no keyboard. There's no mouse connected to this application. It gets all of its instruction via messaging. So again, on this one, it worked really well to use the Azure SignalR service, so that there was a different screen that was effectively the control panel that had buttons, a forward button to go to the next lot for sale, a back button to go to, or update the buyer name, or update the price that it was currently going for, or announcements. So this is another example. So I just want to know the context of a few of those. Now, in today's session, we're going to talk about some architectural considerations that you need to think about with Blazor. We're going to talk about how Blazor uses memory different from some of the other .NET application types. We're going to talk about how hub and spoke patterns really make Blazor applications come alive. Then we're going to talk about different levels of eventing so that you can have interactive Blazor applications. We're going to talk about how to test Blazor applications, and then what it looks like to monitor Blazor applications and get some interesting telemetry from them. All right. Now, Blazor is just another .NET application type. So the good news is when you put together your DevOps environment for a Blazor application, you're going to be able to use a lot from other .NET application types. And if you come to any of our other DevOps webinars in the past, you'll probably see this familiar. It's our clear measure DevOps architecture poster. And one thing that you can see is the Blazor icon. We've annotated on here where you have to do something special for Blazor. And then the other steps that are not annotated is literally there's no difference from any other .NET application when you set up your overall DevOps environment. I'm not going to go deep into this because this is not a DevOps webinar, but if you have any interest, just send me an email. We'd be happy to send you a high resolution copy of this DevOps architecture poster. It's meant to be printed at a print shop, 2 foot by 3 foot. This is the full poster. I was just showing you the top portion. So what you see on the screen now is the full poster. So if you're interested in that, but there's a few things you need to do differently, and I'll cover those. All right, let's talk about source control. Source control. I'm going to show you a little bit of Visual Studio solution organization a few slides from now, but I want to reinforce that a Blazor application is a .NET 6 application or .NET 5 or .NET Core 3.1. But if you're already on .NET Core 3.1, it's a very easy upgrade to .NET 6. So don't put it off, because if you're still using the .NET Core 3.1 version of Blazor, you're missing out on some big changes and some critical bug fixes. So you really want to get up to .NET 6 so that you can use that. And I want to stress that with your Blazor application, you want to have one Visual Studio solution in one Git repository. Now, if you have a system and you're decomposing into multiple different applications, that's great. Put each application in its own Git repository. A Git repository should have at most one versioned software application. Now, when I say a software application in the .NET world, it's synonymous with a Visual Studio solution in that we build, test, deploy, and operate everything as a whole, everything that's in the Git repository. And one application is very normal for one application to have multiple deployed processes. Heck, if you just have a website, a Blazor website, and then you have a SQL Server database, right off the bat, you have 2 deployed processes. SQL Server is going to run in one process on one server, and your Blazor application is going to run on a different server. You put it in Azure App Service, that's your website. You put it in Azure SQL, that's still 2 deployed things. And then, of course, a lot of applications crop up one or many offline jobs. Each of them are independently deployed processes. But if they're all a part of the same logical application architecturally, then they all go in the same Git repository. If you want to make them independent, okay, great. You're sprouting something off into another application and you're putting it in a different Git repository. So I just want to cover that. Now, I'm not going to go over the fundamentals of Blazor. If you're here, you probably have used Blazor, and the basic difference is that Blazor server side actually runs on the server, and we get a Microsoft JavaScript application, Blazor JS. We get a Microsoft JavaScript application that actually runs in the browser, opens a WebSocket back to the server, and then just a bunch of binary messages are constantly streaming back and forth. And if you press the F12 button in your browser and look at the developer tools, then you'll be able to see all those little binary messages going back and forth. And you really can't see, there's no visualizer yet for those messages, but I'm not sure the progress, but the Canary dev ring on the Edge browser has a beta visualizer, I'm told, for for these binary messages, but it's not yet released, not out in the open. But if you click on one of those binary messages, you can see sometimes on render complete, or you can see a little bit about what's going back and forth. And you can definitely see by the size of the messages, which ones are just kind of life cycle events that something happened, and which ones are actually transferring data because you are pushing something, or not you, but the framework is pushing up some changes to the DOM. Okay. Some other changes to some other architectural changes are its intersection with Azure. So if you're going to go to Azure App Service, then you want to make sure of a few of these settings. The first one I'm going to call out is 64-bit, the platform. So many times, and across a number of our clients, we see a few of these mistakes, and they're not intentional mistakes, but it's just how it goes. You start with a test environment using the free tier on Azure, and that's great because the free tier gives you a certain number of minutes per month, and you don't have to pay. But the free tier doesn't support all the features that you're going to need in production, and a few of these features I'm going to call out right now. The first is the free tier of App Service. It doesn't support 32. It doesn't support 64-bit. It only supports 32-bit. But the production servers that you're going to use have more memory than the 32-bit memory space. So if you merely upgrade the size of your app service server instance without changing anything else, you're going to start paying for a server with more memory than your application is configured to be able to use. And it's just going to be a waste. So you want to make sure when you go to the production levels of app service to change the platform to 64-bit. And also a little bit further down, WebSockets. The free tier does not support WebSockets. And so WebSockets is necessary for the built-in SignalR hub that you don't have to do anything. It's just kind of built into Blazor. But with WebSockets turned off, SignalR falls back to JavaScript long polling. And then all of that processing, it consumes a very noticeable portion of the server's CPU in order to do JavaScript long polling. It will functionally work, and you won't really notice until you start to get a little bit more traffic on the server, and you wonder, it's like, why is the CPU pegged? Why are we using all of the CPU? We haven't scaled that high. It's because the server is doing JavaScript long polling and self-hosting at the SignalR backplane. All right, so you want to turn WebSockets on. Now, the second thing you want to do is you want to offload SignalR to the Azure SignalR service. The Azure SignalR service is dirt cheap. We've seen super high traffic and several millions of messages. It's always going to be a rounding error in your monthly Azure bill. Okay, so go to the Azure SignalR service. It is never going to be one of your big line items in your Azure bill. It's just not going to. And it offloads so much CPU from your web server instances running Blazor server side. Okay, and even if you're not using Blazor server side, with any kind of interactive application with Blazor WebAssembly, you're going to want to use SignalR. It's just an obvious choice for non-durable real-time communications. And so make sure you're offloading that hub, the backplane, onto the Azure SignalR service. And then finally, ARR affinity. This is not supported by the free tier. This is sticky sessions. And you won't notice a bug until the first time you scale up to 2 or more than 1 instances in your web service in Azure App Service. So with Blazor server side, this is a big deal because all of the state for a particular user session is on the memory of a particular web server. And so for Blazor server side, it is a must to have ARR affinity turned on. With Blazor WebAssembly, doesn't matter because the web server is only hosting web services and perhaps any jobs that you might have running. All right, wanted to stress on that. All right, so another application is similar space to the livestock auctions, just applied in a different sector, is car auctions. And this is literally the Visual Studio solution structure of an auction application. And you can see the dependency diagram of um, the different projects in that particular solution. You can see that this has two Blazor applications, one called UI, stands for user interface, and the other called UI.admin. And this is a pattern that it's actually not unique to Blazor, but it's a pattern where you have your most of your customers, most of your users use a regular web application, but instead of saying, I need some admin only functionality, let me do role-based permissions, and maybe some of the pages can only be accessed by certain types of users, and then you have this role-based permissions complexity in your application and authorization, everything like that. Instead, the other choice is to create a completely separate application that doesn't even authenticate non-admins. Okay, so it was the choice of, do I add authorization logic and differentiate user types within an application, or do I not even worry about authorization and only allow authentication of admins? And so that choice was made here. Second website, a lot lower scalability needs, but that's called UI.admin. And then you can see with the dependency structure on the left, you can see a onion architecture style of dependency management. Okay, we talk about memory management a little bit. And these are differences. These are some gotchas with Blazor server side. With dependency management, for the longest time, even going back to 2003 with early .NET Framework IOC containers, when they were all third party and Microsoft didn't even provide one, there were 3 levels of scoping, and they were called singleton, transient, and hybrid. Now, when Microsoft created their own and built it into .NET Core, hybrid kind of got renamed to scoped, whereas originally hybrid was for the life of a web request. Well, now it's called scoped. Microsoft gets to build it in and rename things. That's fine. So scoped means for the life of a web request. Now, let's talk about the life of a web request. In Blazor, the Blazor JavaScript file is served up to the browser. The browser then turns right around and opens a WebSocket connection back to the server, and then sits there and waits with an open WebSocket connection to the server, and the original web request never ends. Okay, so the net effect is scoped becomes not scoped as in singleton, scoped to the life of that particular user's session. Okay, very different from the life of a web request. Now it's the life of a user's session, which can last until they close their browser. Okay, singleton is for the scope of the process that it's running. So if you have 2 web servers, then you're going to have one instance of those dependencies on one server, one instance of those dependencies on the other server. And then transient, of course, is get me a new object every time. For WebAssembly, scoped is kind of irrelevant, because the life of a web request is the web request that loaded the WebAssembly application. That WebAssembly application is running in a particular user's browser as an independent process. So the scope of the web request is just as long as the scope of that user's session, which is just as long as the scope of that running process in the browser until they close that tab. So it's going to behave observably the same as singleton. So just want you to know, Blazor WebAssembly, you effectively have transient, and then you have singleton scoped, which are going to be the same. For Blazor WebAssembly, you have transient, then you have scoped to the life of a user's session, and then you have singleton for a particular web server. Okay. Now, in Blazor server side, there is an abandonment logic, and the server will keep all of the memory of a user session for 3 minutes until it can't find that user anymore, and then all that memory will be cleaned up. If on smartphones especially, if someone is browsing a URL and it has Blazor server side in it, and then they turn off their phone and put it in their pocket, well, the smartphone is going to hibernate that browser, and it's going to be disconnected from the network. And the server is going to sit there holding on to that memory of that user session, trying to listen for a reconnect. Now, within that 3 minutes, if the phone comes out of the pocket and all that state is there, and the smartphone browsers kind of reconnect, then the server will reattach. There's really smart logic there. Will reattach the same session, and nothing will be lost until you hit the timeout. That timeout is configurable. If you find that you just have a lot of disconnects, then you can shorten the timeout so that you don't waste as much memory all the time. And if you have low traffic and you don't have any memory pressure, but you have a lot of disconnected users, you can increase that, no problem. All right. I'm harping on several things because Blazor server-side is a new thing. And Blazor WebAssembly is kind of normal, what you would expect. It's kind of a native application. It's running on the user's hardware, CPU, and memory. So you can measure how much you're going to use, and there's not a whole lot of surprises there. And then on the web server side, it's web services. So a lot of people are very familiar with web services. There are no surprises there. Blazor server side is the new thing, and there are a lot of surprises. And so another one is with Entity Framework. Now, if you're using .NET Core, then you need to use the guidance from Microsoft. We included the URL right here on the slide because it's not built in. With .NET 5 and 6, they built this right into the API, and you can say your services collection dot add DB factory, and so effectively this problem is because of scoped dependency management. Normally, Entity Framework likes to be scoped, and so when you say add DB context, it's the same thing as calling add scoped for the life of a web request. For web applications and web services applications, that's what you want for Entity Framework so that it can use the same amount of caching for the life of a web request. But this doesn't work for the life of a user session, where a user session can be days long. If you have an Entity Framework DB context instance that's days long, it could effectively be caching all of the data in the database and just suck up all of your memory, and then accidentally not go back to the database for renewed state and be serving stale data because there's caching built in. And so in this pattern, you want to be wary of that and make sure that you don't accidentally use a scoped DB context for a Blazor server-side application. So be wary of that. All right, let's talk about hub and spoke patterns. Hub and spoke patterns have been around for a long time. They are not new at all. But because so many people have grown up in the last 10 years, primarily working on web applications and specifically state-based web applications, ASP.NET MVC, and then just adding dynamicness to the UI with Angular and React, that hub and spoke patterns are not as common as they probably should be. But in past decades, where desktop software, where native software kind of ruled the roost, hub and spoke patterns were in every single one of them. They were everywhere. And dynamic UI eventing, which we'll talk about later, was in everywhere. So Blazor is bringing the feel of a rich native application to the web world. And now I will admit, there were some segment of people doing React JavaScript applications and Angular JavaScript applications that are also applying this. But again, not the majority of them. So a hub and spoke pattern essentially is a type of abstraction where calling code is going to send data or send a message, send a class, send an object into a hub, into a hub class, a class that has a responsibility for representing the abstraction of a particular wheel, if you will, hub and spoke. And then there are multiple implementations of that abstraction. Abstraction equals interface in C# terms. And then there's a little bit of routing logic that the hub owns to look at the object that is sent in and decide which spoke to send the object to, or which multiple spokes to send the object to. And sometimes the hub will be a broker and it will decide, it will have the intelligence. And sometimes it'll just be a dumb distributor where it will have the object and it'll go around to all of its spokes, and which are classes, and say, do you want this object? Do you want this object? Can you handle this object? Would you like this object? And whichever ones say, yes, give it to me, then it passes it along. So those are two styles. But the calling code, you end up with a single API. And this API, it's just a C# in-memory API. And about halfway down in this code, you see bus.send. Bus is a very common pattern name for a style of hub and spoke pattern. And bus kind of signifies that you send an object down a pipeline and all the spokes are kind of attached and all of them get a chance to speak about it. So a bus is not a broker. A bus is the second style where the spokes decide if they want it or not. Okay, a broker is a different type of hub and spoke where the broker chooses whether to give a spoke a chance. All right, so that's the little semantic differences. And so from the calling code in your Blazor application, to get deeper down into the application, you don't have to have lots of different method calls that you know about. You have one, bus.send. And what do you send? You send three things. You either send a query, which is a request for some data. You send a command, which is an order to do something. Or you send an event, which is just a notification that something happened. And so it really compartmentalizes the user interface of your Blazor application and makes things really, really clean, because you can have your Blazor application on top of, with the bus as a conduit into the rest of the application. And then you just have some routing to the handlers of these particular queries or commands or events. Now, from a concrete perspective, I like to advocate making your own hub and spoke pattern. However, you don't have to do all of the implementation yourself. I really like one particular library, and that's called the Mediator library. And Jimmy Bogard is the maintainer of it. And actually, I interviewed him on the Azure DevOps podcast. We worked together on a project way back in 2008 and 2009. And out of that project, he kind of got the inspiration, and that became Mediator. The pattern was kind of, and he's really taken it really far. But that library has all of the implementation of routing and full support for generics and everything like that. And then what I like to do is take that library, wrap it with another class so that you have a seam or a joint over that library, and then you don't have to do the full implementation of your hub and spoke pattern because you have some help. And that goes for so many libraries out there that do really, really interesting things. And you just wrap the library with your own class. You simplify the API down to maybe the 10% of the library that you actually need for the application. And then your application talks to your wrapper instead of letting the fact that library is used kind of be known throughout the whole application. That's also good practice. So let's look at what my wrapper, my favorite type of wrapper, looks like. It's an implementation of an iBus interface, and there's two things: send and publish. I can send a query, I can send a command, or I can publish an event. Send is one-to-one, single send to a one handler, and publish is single send to as many handlers that want to know that thing happened. And then the method kind of does some instrumentation around it, maybe does some caching, and then delegates to the Mediator library. And in publish, you can also do some interesting routing. One of the patterns that we found really useful in the Blazor space, where we need multiple Blazor users to be notified in real time, like the auction case, publishing events across all of the different servers and then across all of the users that were using the application was important. So whereas normally you might publish an event and all of the code that happens to be living in the current web server memory space get a chance at that. If we route it to Mediator, but then also route it to SignalR, well, now any of the users who are using Blazor who happen to be tied to any number of our web servers that are out there get a chance to receive notifications. So it becomes really intelligent, but the sender of a notification doesn't have to know how complex the routing is. They just know, hey, this thing happened. Everybody needs to know. And then under the covers, we can handle that routing. All right. Also, cross-cutting concerns. When you have a single hub for every button that a user might click in your Blazor application or everything that happens, then you can get a lot of telemetry for free, which we'll show you in a little bit. But if you just have a class like on the screen, record call, and this code is actually taking one of those objects and pulling all the properties out of it and turning it into a application insights custom event, and then pushing it to application insights. So now we have an application performance monitor tool that is recording literally everything that every person is doing in my application. And whether it's Datadog or Splunk or, all the products are so good these days, but just this pattern allows you to do it, because instead of a button on a particular screen calling a method call, which calls a method call, calls a method call, and then you have to instrument everything, if you have every button on every screen, route every query, command, or event to the same hub, routing through the same pathway, well, now you can implement these cross-cutting concerns, and this code can sniff and inspect and gather data from everything that goes through it. And it's a really magical pattern. Okay, another thing for Blazor WebAssembly specifically, Blazor WebAssembly is one web service. All right, now I don't have enough time. I've done dedicated talks on this, gone through the pattern. I don't have enough time to actually dive into it because it's a whole hour long. It's a whole hour long session just in and of itself. But I've included a URL to a GitHub repository right here. And actually, the Programming with Palermo video episode that I highlighted at the beginning, which I'll show you again at the end, is actually episode, I forgot what episode number, but it is a full walkthrough of the code for Blazor WebAssembly with a single web API. Here's the problem statement. The default pattern for Blazor WebAssembly is that you have a page that needs some data, and so it calls a web service, and then you have a web API controller on the server, and it might get some data or do something interesting. Then you have another screen that needs some data. So it calls to another web service, which is another web API controller, which does something. And then screen number 4, 5, 6, 7. Okay, so you get the gist. We get to real applications that have lots and lots of screens and lots of reasons for needing data or needing to process transactions and send some signal to the server. And we end up with a whole lot of web services. Now, if you have a web services SDK and you have web service customers and you need that, well, that's great, because then you layer on Swagger UI, you layer on authentication and security tokens and everything that's necessary to manage public web services. And that's great. Web services are great. But wait a minute. Now I have an application where I have no intention of publishing these web services for any other third-party use. These web services only exist because my Blazor web application needs some way to call over to the server. I really don't care how it calls over to the server. Built into the box is a way for it to do with web services. So, okay, I guess I'll use that. But architecturally, I don't care how it calls to the server. I just want it to work. I want it to be fast, and I want only my application to be able to call in. And I don't want anybody else to be able to get into that pipeline. So the default pattern, though, kind of pushes us to web service sprawl. I have a ton of web services that now have to be maintained for no value of that maintenance. Okay. So instead, don't do that. Instead, steal the pattern from the Azure Service Bus SDK. And it's not a new pattern. In-service bus has been doing this for forever. RabbitMQ, Azure Service Bus, SignalR, the SignalR SDK does this. Heck, SQL Server does this. And that is the concept where in order to talk to the database or in order to talk to the server, there is one connection string. There is one address. There is one address to a queue. And so in doing that, you send multiple message types to that address, and then the server on the other end knows how to sort it out. You can send an infinite number of queries to a SQL Server database through the same connection string, and the SQL Server engine knows which tables to go to and how to sort it out. And so go through this code, and the video is a interactive demonstration of that. This is not slides. This is code and demonstration. So there's a video on programming with Palermo where you can where I walk through and talk through it all. It's really interactive. This is not something that you can demonstrate well just by looking at slides. But in doing so, you could have 100-screen Blazor WebAssembly application, and every button sends a command or a query or an event to a bus, and then the bus hops it over the wire through a single web service, and then out on the server, it routes it to the appropriate handler that can get the data or process the transaction or whatnot. So if you are using a Blazor WebAssembly application, then look at this pattern. Don't just go whole hog into using the default pattern out of the box, because you're going to end up with tons of web API controllers for no benefit of the maintenance overhead that it's going to create just because you have so many of them. And you never intend to support them as published parties anyway. So you're not going to layer on Swagger and all this other stuff. You only need one. You only need one way to jump over the wire and get to the server. All right. So that's a big learning. Okay, now let's talk about Blazor in general. Regardless of its server side, regardless of its WebAssembly, the UI is stateful. Don't plan on browser refreshes. Yes, the code kind of fakes changes in the address bar of the browser. Don't plan on browser refreshes. If you refresh the browser, you're actually going to reload the application. What you want to think, your mindset is to bring back patterns from desktop applications. Okay, so if anyone on your team has done any WinForms, done any WPF, or has done a significant Android application or iOS application, there's patterns there because it's a native, rich, stateful application where you click on one part of the screen and maybe some other part of the screen needs to do something. And so there's two things that I want to talk about here. One is screen decomposition, and the other is eventing. Okay. But I'm going to come back to screen decomposition, but just know you want to factor every logical area of your screen into a different Blazor component. Don't have a Blazor component that has multiple areas of the screen that all do something different. If you can describe what a particular area of the screen is responsible for, factor it into a separate Blazor component. Your life is going to be easier that way, and I'll show you a way to easily compose them. But let's talk about eventing. All right, here's an example. We have and this is from the car application. We need to refresh some details just in case anything has changed and maybe we missed a message, because SignalR is non-guaranteed delivery. Azure Service Bus is guaranteed delivery. SignalR is real time, but it's not guaranteed delivery. Most of the messages are going to get through, but it's not guaranteed. And if you have a network interruption, it's just going to drop. All right, so we have a refresh that goes every once in a while on a configurable time frame. Notice at the top, this Blazor component, regardless of what it is, it has refresh timer as a component in there. All right, so now let's jump into refresh timer. This is a Blazor component that literally has no HTML markup, none, no HTML markup. It doesn't have anything visible. It only has behavior. It has one responsibility: get a setting from the app settings.json file, and on a particular timer cadence, send an event to our event bus. The event is refresh timer triggered, and it's past tense because yes, it happened. The timer got triggered. Refresh timer triggered. Okay, send it. send it down. That's all it does. Okay. So now let's look at code that can do something because of it. All right. This is part of another Blazor component, and it implements some interfaces. Look at the top. iListener of type, and there's actually multiple event types. iListener of type refresh timer triggered, the third one down. And notice the handle method for refresh timer triggered. And what does it do? Refresh the entries of the auction. Okay, so this is how within a particular user interface, one part of the screen can have a component, and instead of trying to have multicast delegate events like .NET events that are subscribed to a parent component's event, which then the parent tries to jump over to the master page and then tell something in a child component down here to change something. Instead, every component that's alive in memory on a particular screen is connected to the same eventing bus. So this is a different hub and spoke pattern than the bus that goes down into an application and towards a database. This is within the user interface an eventing bus. And so any component anywhere on the screen can throw an event down this bus. Every other component gets an opportunity to say they're interested in it by implementing the interface iListener of type of that event. And then the bus knows that they are interested in that particular event and will just pass it on to their handle method. And then that component can do anything. So a component on one side of the screen can send an event, and there could be 10 components in a list on the right-hand side of the screen that all independently get to choose what they want to do when that event happens. Really powerful. All right, let's talk about composition now. All right, here's a library that I actually put out earlier this year, and it's called Blazor MVC. There's actually some user group talks and a previous Clear Measure webinar where I've gone through Blazor MVC, another bigger topic than we have time for. It would take its own hour just to go through it. But go to NuGet.org, look for Blazor MVC. The URL to the Git repository is there. You do all the code, either use it as a library or grab some of the interesting bits. It has an eventing bus implementation in it, and it has a handler bus that implementation in it. But effectively, this makes it really easy to create a model view controller pattern in our application. Let me tell you what I mean. And if you're not familiar with a model view controller pattern, just search the web. You'll probably find some original papers from 1975. It's a really old pattern. And then of course ASP.NET MVC applies it to stateless web applications. But let's take the counter controller and let's separate the controlling logic from the view logic. And so here we have a counter controller. We say, you know what, the controller needs to happen first. The controller needs to get on the call stack first and decide whether or not it wants to use the counter view or something else. So the counter controller happens first. So we give the routing responsibility to it. Notice the route attribute above it. Now the @ symbol page in a Blazor component, that just compiles down to a route attribute anyway when it compiles into assembly. So it's the same. It's literally the same code. So the controller happens first, sets some information on the counter view, and then responds to the on click as an action, as a callback. And so that's the separation. All right. So go check out Blazor MVC. That's all I'll talk about it now. But that enables you to separate what something looks like from what something does in a Blazor application. And for simple Blazor applications, okay, you don't need any separation. You're going to be fine anyway. But real sophisticated growing applications, you need to implement patterns like this. Okay, now let's talk about responsibilities like abstractions and startup. All right, let's just take the example of Blazor WebAssembly. You're going to get right out of the box, you're going to get a project for the client, you're going to get a project for the server, and you're going to add other projects that talk to a database and whatnot. We all know this time tested. We don't want to couple our user interface with data access or directly to any other dependencies. So we separate our code, we separate our data access code to its own library and have it implement abstractions that are defined by a core project. And the core is kind of the center of our application. It has all of our entities, it has our data access interfaces, and our user interface code does not have a reference to data access. It has a reference to core, to the abstractions. And then we use the services collection inversion of control to get implementations of those interfaces, which, by the way, happen to be classes in the data access project, which implement those abstractions interfaces that are in the core project. Okay, so that has been long established. And if that's a new concept for you, just search onion architecture. There's plenty of material about onion architecture, and even in the Java industry before that, hexagonal architecture. And there's plenty of examples there. Actually, I have a multi-part onion architecture walkthrough on programming with Palermo that's halfway published so far. So you can check out some of those videos. But this is what I want to talk about. One responsibility in a Blazor application that's not factored away from your logic is the responsibility of starting the application, starting and configuring the application. Now, the default template puts all of the configuration and startup logic in the program CS file in your server application. All right, where we create the host builder, we set up the services collection, we add Blazor, all these things, and then we call build and we call run. Okay, so that is configuring the application. We read in app settings.json and all that. So we configure and then we run the application, start up the application. That's a responsibility. That's an important responsibility. And the code that does that cannot be the same assembly that defines abstractions, because they're different. If you are the code that defines abstractions, then all the other projects in your Visual Studio solution reference you, and you reference none of them. You're not even aware that they exist because they implement your abstractions. You don't care if they do or not. But the code that configures and starts up the application is totally opposite. It can't implement any abstractions because it has a reference to all your other projects. Your other projects don't have a reference to it and don't even know it exists. In order to configure the whole application, you have to know about the application. So that is your promiscuous project. You know about all the other applications because you have the responsibility of configuring and starting up. Now, by default, the template puts your web API controllers for your web services, and I advocate only having one, in the startup project, which configures and starts up, and by its nature has to be promiscuous and have references to every other project in your Visual Studio solution. So this pattern here that I want to highlight is factoring out your web services into a different project. And on the right-hand side of the screen, I called my application UI. So I got UI.client, UI.server. And so I've created another one called UI.api. I have UI.api referencing core. And then I have UI.server stripped out of anything else except configuring and startup of the application. So if you see on our dependency diagram on the left side of the screen, UI.server is hollowed out to just the configuration and the startup responsibilities. It has references to the other projects in the Visual Studio solution. UI.api has our web services, which is going to end up having server-side logic. And then we have our web services with no intimate knowledge of our web assembly, and neither of them have knowledge of data access. It's all properly structured. We're making use of the abstractions in our core project, and yet we have a very thin but effective startup project, which is in this case is UI.server. And then all the debugging in Visual Studio works appropriately and everything gets started up because the WebAssembly debugging is hooked up and everything like that. And then your integration tests that have to know about everything, they can just reference your server project and you get all the rest by flow through. All right, that's a big idea. Okay, I'm going to blaze through. We got a few more things to talk about, and I'm going to encourage you to press F12 on Blazor server-side applications when loading big lists so that you can see how the DOM interacts. But there is there's something that causes a page to hang or seem to hang and sit there when it's loading, say, 100 images in a list of, not grids, but a list of things, because the DOM is doing kind of 100 DOM transactions. You can get around this in Blazor, and actually, I think this applies to either version of Blazor because you're still using the DOM. It doesn't apply to Blazor native applications because you're actually not doing DOM interop. But if you take the first 10 of a long list and bind it or set it to the variable that a loop is bound to, and then call state has changed, that'll do a 10-item transaction in the browser DOM, and the user will see something really quickly. Then behind the scenes, put the other 100 behind it and call state has changed again, and it'll append to the end of the list. If you don't do this, the browser won't show you anything until all 100 of those items are bound into the DOM. And so that'll be a noticeable lag. You say, man, why is this screen so slow? So that's just a little tip. And you can test this, believe me. I talked about broadcasted events. This is something, this code actually hangs off of the bus and takes broadcastable events, objects that represent or implement a particular interface, a marker interface, and send them through SignalR. Okay, so that's another cross-cutting concern example. I also want to show you how unit tests look for Blazor components. This is server-side or WebAssembly. You want to use the bunit library, layer it on top of InUnit for running tests, and you can literally create a single Blazor component. You can set its parameters, you can stub out its dependencies, you can run it, and then you can make sure that certain HTML elements were created, are visible, and have the right data in them. And this is what that looks like. Now, when you deploy to a TDD environment, a test automation environment at the start of your automated deployment pipeline, you want to run full system acceptance tests through the browser. And so you want to use Selenium for that. Playwright is a new library that Microsoft is playing with. It's early, but Selenium has been around for a long time, well over 10 years. And that is right today, as I speak, that is the library you want to use for full system testing of Blazor. You'll be able to hook some of the events, but you're not going to get away from doing some thread.sleeps in some situations. That's what we found, unfortunately. So these tests are considerably slower, but you want to have full system acceptance tests that run completely through the browser on a deployed system. And so, this is kind of what those Selenium tests look like. You want to have every one of these full system acceptance tests responsible for their own setup. So you kind of use your data access layer, throw data into the database at the beginning of a test, and then have common navigation. Okay. So this is the setup, and then you have your act and assert, arrange, act, assert, and the asserts use the Selenium driver to do certain things. All right, let's finish up with monitoring, and I want to show you something really, really interesting that happens when you use a hub and spoke pattern, and that is to pull interesting telemetry like this. So this is kind of an older slide. You can see by the dates, but when you take every command, query, and event that goes through that hub, that bus pattern, and you send them all to Application Insights or Datadog or Splunk, now you have names of custom events, and now you can graph them, you can chart them over time, and you can count them up and start to derive some metrics. So we can see that we have this by the way is from the car auction application. We have weekly seasonality, but over the course of the summer from July through August time period, there was a steep ramp up in these types of messages running through the system. So that's really interesting. I will also share some in production. You do want to be using the P3 instances. P3 instances came out in November. And I interviewed Stefan Shakow, one of the architects on app service for the Azure DevOps podcast, and he recommended for any Blazor server-side applications that use a little bit more memory, P1 V3 is the smallest server size that they would recommend for Blazor server-side applications. And then P3 V3, man, that is a beast of a server right there. Okay, finally, for Blazor server-side applications, these two metrics we found to be really, really instructive. The server response time, as long as we were 10 milliseconds or less, the user could not tell any kind of noticeable delay in any part of the application. And as long as the average receiving response time was under 100 milliseconds, they couldn't tell. Once either of those kind of started going beyond those thresholds, then it started to become perceptible that, oh, okay, now I had to wait a little bit. So those were good heuristics for a Blazor server-side application. For Blazor WebAssembly, it's the same metrics for any other web service application that you might happen. And then finally, connected circuits for Blazor server side is one that we looked at. So here's just one example on a low traffic day, but average open circuits on the top right. We measured the number of connected Blazor server side circuits that we had. And I think on this chart, there's 4 web servers in the farm, just to kind of show, just to test. And we can also measure the disconnected circuits that are disconnected, but not yet memory reclaimed. And so how do we do that? There is a special circuit handler class abstraction that you can implement, you can override, and you can do some counters. You can do however you want to. In this case, you just count them up, you throw them to application insights as a custom metric, and then now you have the metric, you can graph it. So you add that to your services collection, and now anytime someone connects or disconnects, you get a placeholder where you can execute some code. So that was really interesting. All right, that is a lot. I know I've gone over by a few minutes. I want to put back up this information with my email address and information. Go to www.palermo.network for the new TV show. You can see the Blazor WebAssembly with a single web API episode there. Thank you all for coming to the webinar. I know I told you this is a lot of information, and we were going to go fast. I answered some questions that came through during the webinar. For those of you who want to dig deeper or have some other questions, just send me an email. I love to. We can get on a Zoom call or whatnot. I love helping people, and this is fun for me. And so I hope this was helpful. Again, if you have any questions, or if ClearMeasure can help you on a project, we are a software architecture company that helps .NET teams move fast, deliver quality, and run their software with confidence. And so we love helping our clients have to outsource less. We love helping our clients do more internally. That's our goal, is to up-level the internal team. So thank you very much for attending today's webinar, and make sure to check out the webinar that will be announced for September. And have a great day. God bless.